On 1st January 2025, the Faber car company will release a new car to global markets. The company expects to sell 40 cars in January 2025. The number of cars sold each month can be modeled by a geometric sequence where R is equal to 1.1. Letter A, use this model to find the number of cars that will be sold in December 2025. The number 40 cars, is the first term of the sequence because it's the number of cars sold in January. In December is the 12th month of the year. We want to know what is U12, knowing that the common ratio is 1.1. We use the formula from the formula booklet. UN, the nth term of geometric sequence, UN is equal to U1 R to the n minus 1. In this case, where n is equal to 12. So U12 is equal to U140 times the common ratio 1.1 to the power of 12 minus 1. So we can just use the calculator to find this value. I'm going to use the calculator Casio. 40 times 1.1 to the power of 12 minus 1, which is 11. The number is 114.12. This rounds to 114. So that's the number of cars that the company expects to sell in December. Now going to letter B, use this model to find the total number of cars that will be sold in the year 2025, 2026. To do this, we need to add all the terms of the sequence, considering the sequence from in January, U1 up to U12. So we are going to add the 12 terms of the sequence. This is S12. Using the formula from the formula booklet, I'm going to use this first version of the formula. Sn is equal to U1 R to the n minus 1 over R minus 1. S12 is the first term 40, then the common ratio 1.1 to the power of 12 minus 1 over 1.1 minus 1. Then we can get the calculator to write this expression, 40, 1.1 to the power of 12 minus 1 over 1.1 minus 1, which is 0.1. So the total number of cars, 855.37, 855.37, which rounds to 855. Alternatively, without using the formula, we can use sigma notation. Let's call this method that I just used to solve as method 1. Method 2 could be, rather than using the formula, use sigma notation using the general term of the sequence. So we could use the sum of all the terms in the sequence, starting at n equals 1 up to 12 of U1, which is 40, times 1.1 to the power of n minus 1. In this case, the advantage is that you do not need the formula. You don't need the formula for this case. So what you do is you come here, go to math, and then go to sigma, and then you complete this. Here, to be easier, I use x rather than n. So 40 times 1.1 to the power of x minus 1. And then x going from 1 to 12. And this gives the same answer. So this is also with 855. All we did here is part B1. For part B2, 2026, then we have some alternatives for 2026 because we know the terms from 2012, from 2025, we already know the sum of the terms of 2025. Now to 2026, we could add the 24 terms of the sequence. And then, because then we would be adding 2024 and 2025 by using first term 40, 1.1 to the power of 24 minus 1 over 1.1 minus 1. If we do this, we find the sum of the number of cars from 2025 and 2026. So I come here and change this value from 2012. We change the index 12 to 24, and this becomes 3,539, 3,539.89. But this includes 2025 and 2026. We want only 2026. So what we do, we subtract the number of terms from 2025. We have found this previously. So we do 3,539.89 minus 855.37. And then we round this answer at the end, 3,539.89 minus 855.37, 2,684.52, and this rounds to 2,685. Using another method, using again sigma notation, this time we could add the terms starting from the 13th month up to the 24th month. And then this would be simpler in just one calculation. We expect to find this result. So all we would have to do is come here and change this 12 to 24, change 1 to 13. And then what we get is the value that we found, the same value, 2,684.52, that also rounds to 2,685. This same process using sigma notation can be used in the calculated taxes. So if we go to the normal screen, we go to math, and then we select summation. And then it's the same idea, come here and use X. For example, for the first value, for the first answer, 40 times 1.1 to the power of X minus 1. That result. And in Nspire, in the normal screen, we would go to, there is a place here, this button, and then we select sigma. And then again, we use any letter we want, let's say X, from X equals 1 to 12. And then here, 40 times 1.1 to the power of X minus 1. And then we expect to have the same answer. That's it. So the use of sigma notation can sometimes make the calculations easier, especially here in this question.